When you picture Stonehenge, you see this, right? These ancient stones standing silent on a huge, dry, grassy plain. I mean, it's an image that's basically burned into our collective brains. But what if that whole picture, the very ground it's all built on, is just wrong? Okay, let's get into this, because some new evidence suggests we might need to completely rethink this iconic landscape.
Just imagine this for a second. Instead of a lonely hill, what if Stonehenge's earliest days were spent right up against a body of water? Not some monument in the middle of nowhere, but a structure right on the edge of a busy waterway. And look, this isn't just some wild fantasy, it's a real possibility that some pretty startling physical evidence is pointing to.
So here's the real conflict. The familiar story, the one we've all been told, is all about these symbolic wooden posts that were placed on a dry chalk hill way before the big stones ever showed up. But the physical evidence, when you learn how to look at it in a new way, tells a totally different story. It tells a story of a water margin, a shoreline that's literally written into the geology right under the site itself.
To really get to the bottom of this, we're going to walk through 3 separate mathematical proofs. And these proofs argue that early Britain wasn't the landscape we think it was, but something they call a high-water world. And you know what the best part is? These proofs don't rely on trying to interpret what some artifact meant. They rely on cold, hard physics.
Now, this is what's so powerful about this whole approach. We're not talking about archaeological theories that, people can debate about forever. The source material is really clear on this. These are physical limits. They are hard constraints on what the world could have been like, based on things like mass balance and simple proportions. You just can't negotiate with physics.
So, let's kick things off with our first proof. It's a huge global-scale puzzle, and it's called the discharge paradox. And like any good mystery, it starts with a really simple question that has a very, very complicated answer. Here's the paradox in a nutshell. We have these incredibly detailed records showing that sea levels kept rising by tens of meters after the major ice sheets had already melted away. So if the giant taps of glacial melt were basically turned off, where in the world was all this extra water coming from? It couldn't be rain, not nearly enough to do that.
And this chart just perfectly lays out the scale of the problem. For every single unit of water that we can account for from the sources we know about, like leftover ice melt, the sea level data tells us we actually need something like 3 units. There is a massive, massive volume of missing water that has to be coming from somewhere.
Well, the only physically possible solution is that the land itself was the source. I want you to picture the entire landscape after the Ice Age as a giant waterlogged sponge, just totally saturated with meltwater. And then, for thousands of years, it slowly drained all that water into massive river systems, which then fed that sea level rise long after the glaciers themselves were gone. This isn't just a cool idea, it's a volumetric necessity.
Okay, on to proof number 2. So, if the whole landscape was draining all of that water, how high would the rivers have actually been? Well, this is where something called the terrace rule comes in, and it connects the volume of ice on the planet directly to the height of its rivers.
The rule itself is actually pretty simple. We know that at the last glacial maximum, the planet had about 90% of the absolute maximum ice it's ever had. So if the all-time max level of ice created the highest river terraces we see today, then it just makes sense that a 90% ice volume had to have created rivers that flowed at the next level down. It's not a model, it's just a proportional inevitability. It's like a tide mark left behind by the Ice Age.
And here's the really big takeaway from that. Any picture you've ever seen of ancient Britain that draws its rivers inside their small modern-day valleys, well, it's physically inconsistent with the ice volume data. It's impossible. If you accept how much ice there was, you absolutely must accept that the rivers were way bigger and much higher than they are today. The two things are totally inseparable.
So we've got a global water paradox, and we have a physical rule for how high the rivers were. Now for our third and final proof, we're going hyper-local. We're going to zoom right in on the ground directly beneath Stonehenge, using borehole data that's been sitting around for years, just waiting for someone to look at it in a completely new way.
The key innovation here was this really simple but profound shift in how they analyzed the data. See, traditionally, geologists would look at borehole data by depth from the surface. But the ground surface is uneven, right? So the big breakthrough was to analyze all the data by its absolute height above sea level. When you do that, you can compare all the different boreholes like you're looking at one single, consistent slice through the landscape. And as soon as they did that, patterns just jumped out at them. Let's look at the evidence right around the 92.6-meter elevation mark, which, by the way, is exactly where those famous Mesolithic posts were found. First thing they saw? Shells. And not just in one spot, but in at least 6 different boreholes, all clustering right around this specific height. This is not some isolated fluke.
Next, let's add cobbles and gravels to that. Now this kind of material, that means you've got higher energy water, a flowing current. And where do they find them? You guessed it, in multiple boreholes clustered right at that same elevation band. We're starting to build a picture here of different kinds of water activity all happening at the very same height.
And to complete the picture, you find sands, silts, organic staining, even peat, all clustering in that exact same vertical zone. Just think about it for a second. You've got all these different types of deposits, from low-energy shells to high-energy cobbles, and they are all being controlled by the same elevation. This points to one single, fluctuating system, a shoreline.
Now, this isn't just a gut feeling. It's straight-up statistics. The researchers actually calculated the odds of these 16 different water-related deposits all clustering so tightly in this one elevation band just by sheer chance. The odds against it? About 170 to 1. At that point, you have to throw out the idea of randomness. Something structured this environment.
And this brings us right back to the archaeology. Those ancient Mesolithic post holes, the very first human activity we know of at the site, they sit right at 92.6 meters. They are located squarely inside the statistically proven elevation-controlled water margin. They weren't just placed on some random dry hill. They were placed right at the water's edge. So where does all of this leave us? We've just looked at 3 completely independent lines of evidence. Now let's put them all together and see the inescapable conclusion they force us to accept. And this isn't just about one monument. This is about the fundamental rules of the ancient world. And this just perfectly shows the power of the argument. You have 3 proofs that reinforce each other perfectly. The global mass balance proves there was a massive amount of freshwater drainage. The ice volume scaling proves that drainage created enormous high-level rivers, and the local borehole data proves exactly where the edge of one of those water systems was, right at Stonehenge. This quote from the source material just gets right to the heart of it all. This isn't about arguing over whether a post was for a boat or a fish trap. No, it's way more fundamental than that. It changes the physical stage on which all of ancient history played out. It rewrites the very boundary conditions of the world our ancestors actually lived in. So the bottom line is this. The evidence demands a completely new interpretation. The earliest structures at Stonehenge were not some abstract symbolic markers put on a dry, empty hill. They were practical, functional structures built on a shoreline in a world that was absolutely defined and dominated by water. And that leaves us with a final, really provocative thought. I mean, Stonehenge is one of the most studied places on the entire planet. If our basic understanding of its landscape, the very ground it stood on, was wrong for this long, what else are we getting wrong? What other certainties of ancient history are just sitting there, waiting for a fresh look at the data to be completely rewritten?